This is an economizer. It's a piece of equipment commonly used in factories behind steam boilers, thermal oil heaters or drying processes to recover waste heat from flue gases and reduce energy consumption. I will explain the working principles, the different uses of it, the common problems that can be encountered and how to solve them, and I will explain how much this heat exchanger behind me will save in energy when it's installed. At Heat Matrix, we help industry to become more sustainable and reduce energy consumption by waste heat recovery. We have implemented multiple economizers at our customers, just like this one that will be installed in a couple of months from now at a distillery. Let me explain what is an economizer. Economizers are typically installed behind steam boilers, thermal oil heaters or drying processes. By waste heat recovery, you reduce your energy consumption, your CO2 emission and your cost reduction in the end. As a rule of thumb, every 20 degrees Celsius reduction of your flue gas temperature around the steam boiler leads to 1% energy efficiency improvement. An economizer recovers waste heat from flue gases. Tubes are installed in the flue gas stream. Flue gas flows around the tubes and inside the tubes cold water is flowing and is being heated up. So the heat is recovered from the flue gas into the water. In general, the heat recovered by the economizer can be used in three different ways. It can be used to preheat the boiler feed water or makeup water in the steam boiler. It can be used to preheat process water for circumstances and processes outside the boiler. Or it can be used to heat up a water glycol system or a thermal oil loop to use the heat somewhere else. So when preheating boiler feed water or makeup water, instead of sending cold water into your steam boiler, you use the waste heat from the flue gas to heat up that water and have a fuel reduction in your steam boiler. If you heat up the process water, you can use it externally, for example, if you need hot water in your process for cleaning purposes. And the third is using it for water glycol heating or thermal oil heating and transport the heat to another location where you want to heat up something else. It's crucial to define the right economizer specifications for the situation it will be operating in. If not done correctly, this will lead to higher maintenance costs. This can be caused, for example, by failure of welds due to thermal stresses, or it can lead to efficiency loss caused by fouling and/or corrosion. So what are the options and specifications to consider when designing an economizer? So materials of construction can be carbon steel, stainless steel, or even polymer lined in case of highly demanding applications. Tube types that can be considered are bare tubes or fin tubes to get a more compact design. The tube fixation can be done on one side, so tubes are welded on one side, or on both sides, depending on the thermal stresses you expect in your process. And the fourth option to consider is, do you require inline cleaning or not, to keep the system clean if you have a dusty environment present. I will go through 4 different usage cases. So the first case is a clean flue gas that doesn't contain dust or fouling. In that case, carbon steel with fins can be considered to have a compact and economic design. The second case, where you expect corrosion, it's better to use bare tubes because fins tend to corrode away, and use a material of construction that can deal with the environment that's present. So if you cool through the acid dew point, you should go for a polymer lined type of system that can resist high corrosiveness. The third usage case is a heavy fouling circumstance. In that case, it's best to use bare tubes in combination with an inline cleaning system. Finned tubes would clog up, and if you wouldn't use inline, your whole system will fill up with fouling in the end and you will not have a functioning heat exchanger. So the fourth case of operation is usage for very high temperatures. In that case, it's best to have your economizer build up with a tube sheet just on one side, so that you have free floating tubes and prevent buildup of thermal stresses. Like I said in the beginning, as a rule of thumb, every 20 degrees Celsius reduction in flue gas temperature equals 1% efficiency improvement of a steam boiler. The economizer behind me will be installed behind the steam boiler at a distillery. It will treat 10,000 kilograms of flue gas, leads to a cost reduction of 120,000 euros per year and 520,000 kilograms of CO2 emission reduction. If you have a situation where an economizer could be useful, please click on the link below and we can help you and advise on your case. If you found this video helpful, please like this video and subscribe to our channel to be notified when there are more videos like this.